Good day, class. We want to solve the last class on our polygon with this question by solving this problem. In our previous video, we have talked about the sum of the interior angle of a n-sided polygon n minus 2 times 180 or 2n minus 4 right angles. The number of sides of a regular polygon is n equals to 360 degrees over e, and that the interior angle plus exterior angle will add up to 180. So we want to use that concept now to solve this problem. The interior angle plus exterior angle of any n-sided polygon, the addition is 180. So look at this problem. Each interior angle of a regular polygon is 120 degrees greater than each exterior angle. What is the special name of the polygon? So we have solution. This statement means a lot. 120 degrees greater than each exterior. We don't know the exterior angle. We can say let the exterior angle be E. So if this is E, and we are told that the interior angle, if the exterior angle is E, then interior angle is 120 degrees greater than the exterior angle. That means the interior angle will be 120 degrees plus E. 120 degrees plus E. And we know that interior angle plus exterior angle will give you 180 degrees. So if our interior angle is 120 degrees plus E, and our exterior angle is E, then the addition will give you 180 degrees. So when you add it up, we have 120 degrees. E plus E will give you 2E. That will give you 180 degrees. So 2E will be 180 degrees minus 120. So 2E will be equals to 60 degrees. So E will be equals to, you divide both sides by 2. So that will give you over 2. So 2 cancels 2. So E will be equals to 30 degrees. The exterior angle is 30 degrees. So the question says, what is the special name of the polygon? We know that from the concept of polygon, n is 360 degrees over E from our last class. So that will give you 360 degrees over 30 degrees. So 0 cancels 0, 3 here 1. 3 in 3, 1, 3 in 6, 12. So this is 12 sides. The polygon with 12 sides, we said polygon with 4 sides is quadrilateral, 5 is pentagon, 6 is hexagon, 7 is heptagon, 8 is octagon, 9 nonagon, 10 decagon, 11 undecagon, 12 is dodecagon. So this is dodecagon. So the polygon we've actually calculated is a dodecagon. Hope you have gained something in this video. See you for many more problems on polygons. I think you have gained something today. Bye for now. See you in my next video. Bye.